So in this video, we're going to expand on the counting rules. So the first definition we need to talk about is in factorial. So it's read in factorial. This is the total number of ways to arrange n objects. Okay, so defining it as n factorial is equal to n times n minus 1 times n minus 2 all the way down to 4 times 3 times 2 times 1. Okay? So to give you a concrete example there, say I had like 5 factorial. How would I do this? This would be 5 times 4 times 3 times 2 times 1. I multiply by all the integers less than or equal to the number factorial. And I get 120 if I multiply this out. Okay? 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, which is really 6 times 5 factorial, right? So it'd be 6 times 120, which I think is 720. Okay, so these numbers get really big really fast, right? To do factorial in your calculator, you're going to hit the 5 button, and then you go to the math, and then you see at the top a prob. You're going to go over to PRB, and then you'll see the factorial button, and you'll hit enter, and then hit enter, and you'll see the 120. Guys, if I did like, I don't know, 15 factorial, this is probably going to be pretty big. Do enter and see, look how big that number is, just starting to get really, really big, right? So that shouldn't be a decimal. That's got to be some type of mathematical error. It's just, that's just such a big number, and your calculator probably won't even let you do it. Okay, so the thing to remember of factorial, this is how many ways I can rearrange those n objects. So if you think about it, you had like n equal to 3. 3 factorial is 3 times 2 times 1, which is 6. So say you have a, b, c. How many ways can I rearrange a, b, c? Well, I can make it a, c, b. I could also make it b, a, c, b, c, a, c, a, b, and c, b, a. Okay, that's 1, 2, 3, 4, 5, 6. There's 6 ways to rearrange ABC, okay? So that's the idea behind factorial. Tells you how many ways you can rearrange those n objects. So this definition here is permutation. Permutation is the arrangement of objects in which order matters. The order matters. What does that mean? That means ABC is different than ACB. These two things are different. The order matters. Key difference there, order matters between that and the next definition, right? So permutation is one in which the order matters. Now, with a combination, this is an arrangement of objects in which order does not matter. Order does not matter. Okay? So ABC is the same as BAC. These two are the same here. All that matters is that we have the elements A, B, C. We can find them. There's an A there, there's a B there, and there's a C there. So it's considered the exact same thing. So when you're talking about like a passcode, if your passcode is 1234, by golly, if you try to type in 4231, that's not going to work. The order matters there. So that's a scenario where the order does matter. But if you're talking about like a lottery ticket and the winning numbers are 1, 2, 3, 4, then you can buy a ticket and buy the ticket, and on the ticket it says 1, 2, 3, 4, or 2, 1, 3, 4, and you still win. It's the order that does not matter. It's just having the 1, having the 2, having the 3, and having the 4. That is the definition of a combination. Okay? A combination. Now, sometimes you run into the scenario where you have to do weird math, and it's kind of like you take 5 factorial divided by 3 factorial, okay? And so an easy way to do this is if you write it out, you see that you have some cancellations going on. This 3 cancels this 3, that 2, and that 2, and that 1, and that 1. So what are you really left with? 5 times 4, which is 20. Okay, so it can simplify. So if you had like 20 factorial divided by 18 factorial, that'd just be 20 times 19, all right, which is a lot easier than trying to do that. Now, you could do that in your calculator. You just have to be careful putting parentheses around it so that you don't end up doing something silly, okay? When you're dividing, you got to be careful. All right, so we're going to do a problem where we have 20 students in the class, and we're going to elect a president, we're going to elect a vice president, and we're going to elect a secretary. And I want to know how many different ways, how many different outcomes are possible if only one person can fill each position. So when I see a how many problem, I'm thinking counting principle. So I go back. Counting principle, I got to figure out how many steps there are, how many ways to complete each step, and multiply. All these problems break down into that. So what am I doing? I'm electing a president, a vice president, and a secretary. So I need to put a step for the president. I need to put a step for the vice president. And I need to put a step for the secretary. Okay? Now, how many ways can I pick a president? Well, if there's 20 students, then I can pick 20 people to represent this first president spot. Okay? Now, if I pick somebody, say I pick Bill to be president, can Bill also be vice president? No. Each student can fill only one position. So now I only have 19 students left to choose from for VP. And once I pick a VP, Sally gets picked VP. And then I'm going to pick a secretary. And Raul's going to be the secretary. And there's only 18 left to choose from at that point. Now what am I going to do? I'm going to multiply through. And what do I get? Well, when I multiply this through, I get 6,840. How do I know that there aren't any repeats? Well, if Bill is president, Sally is VP, and Raul is secretary, that would be a very different scenario than Raul being president, Bill being VP, and Sally being secretary. Okay? Very different scenario going on there. All right? So, does order matter? That's what we have to ask ourselves. Does order matter? Well, I think it does. Because if we change the order in which we pick the people, then all of a sudden we can tell the difference, right, between president, vice president, and secretary. Order matters when you can tell the difference. There's a difference in the positions, okay? So yes, order does matter here. Now, there's a formula for a permutation. And for a permutation of n objects chosen r at a time, the formula is equal to n factorial divided by parentheses m minus r factorial. Okay? Now, how many people were there total? There were 20 people in the classroom, and we chose 3. Okay, so how does this work? It's 20 factorial divided by parentheses 20 minus 3 factorial, which equals 20 factorial over 17 factorial. But guess what, guys and gals? When I multiply this out, what do I get? I get 20 times 19 times 18 times 17 times 16 all the way down, divided by 17 times 16 times all the way down. Look, all these numbers cancel with all those numbers, so what does it end up being? 20 times 19 times 18, which is exactly what the Clark way said to do, 20 times 19 times 18. So if you want to use the formula, great. Use this formula right here, okay? If you want to use my way, where it's just a fundamental counting principle, draw lines and divide, personally to me, this way makes more sense, okay? It's easier. Same thing here. Now, the only thing different, we've got 20 students, but we're going to form a committee of 3 people. So on this committee of 3 people, I have 3 steps. Now, it doesn't matter if I pick Raul first, then Sally, then Bill, okay? Or if I pick Bill, then Sally, then Raul, right? That does not matter. It's still the same committee. It's the exact same committee, okay? You can't pick the same person more than once. So the first guy or gal is 20 options. The next one is 19, and then the last is 18. But we have a repetition going on here because Raul, Sally, and Bill is the same committee as Bill, Sally, and Raul, okay? So we need to divide out repetition. Well, how many repetitions are there? You got to think about this. R, S, and B, right? Raul, Sally, and Bill. I can write it RBS. I can write SBR. I can write SRB. I can write BSR and BRS. How many total is that? How do I know that that's all of them? Well, how many are there? There's 3, so 3 factorial is equal to 6. So I got to divide out, because there's 6 of these repetitions. I need to divide out by the number of steps factorial. How many steps are there? There's 1, 2, 3 steps. 1, 2, 3 steps. So I take 20 times 19 times 18, and I divide by 3 factorial, the number of steps factorial. Why? Order does not matter. Order does not matter here. This is a combination. A combination. So if I do that, what do I get? I get 1140. Okay, you can type it in your calculator. 20 times 19 times 18, divide by 3 math prob factorial, enter 1140. Okay, now what is the formula? It's NCR equals n factorial divided by n minus r factorial times r factorial. So what's going to happen here? N here is 20. 20 minus, and r is 3 again, factorial, and then 3 factorial. So this is 20 factorial over 17 factorial, 3 factorial. And remember, we just calculated 20 factorial divided by 17 factorial, didn't we? We got it to be 19 times, or 20 times 19 times 18. And so this, my friends, is where that extra 3 factorial comes into play there. It's dividing out the repetitions that we wrote out right here, because these are all the same group. They're the same committee. We can't tell the difference. Therefore, order does not matter. And if order does not matter, it has to be a combination. NCR, okay? So how would I do NCR this in my calculator? So y'all's is a little bit different than this one. In your calculator, you would do 20, and then you would go to math and probability, and you'd hit the NCR button and hit enter, okay? And then at that point, after you do that, you'd hit the 3 button. In this calculator, I got to do it a little bit differently, so don't really pay too much attention to what I'm doing here. Let me see if I can get it. So math, goodness. Math, probability, NCR, 20, and then 3, and that gets me the 1140, okay? Same thing if I did math. You see the NPR, NPR is what you're gonna use for permutations. NCR is what you're gonna use for combinations. So you need to be able to write out this formula and then plug in those numbers. The N here is 20 and the R there is 3. There's 20 people total. You're choosing 3 positions, okay? And you're dividing out by the number of steps factorial there.